Yo, okay, hello. Hey, folks. Can you hear me all right? Hi, Rebecca. Hi, Michael. All right, hopefully things are going to look all right here. I'm just setting my screen up now that I'm sharing a tab. Okay. Hi, Steve. Hi, Bailey. Okay, great to hear everyone can hear. I know there's going to be a slight delay. First, we're going to wait for people to join in. I'm going to move some things on my couch. I just got home from school. I was on campus today doing some work. Great, we got 10 people in right now. I'm going to share the link on some Discords really quick, make sure people know what's chilling. Great. Okay, let me pull everything up. Hi, everyone. We've got 12 people in right now. I'm sure a lot of people are going to be watching the live recorded session. It's going to be so great today, and you're all going to tell your friends about our amazing session that I'm running. Cool. So, yeah, hi, Fayaz. We'll wait for people to join. I'll bring in this. Awesome. Let's see how that is. Cool. I think that's all right for now. Cool. Can I bring on like a web notepad or something? Cool. Hello, deep fried pancake. How's your machine learning assignment going, pal? Hope it's going well for you. I assume you finished already, so you know. Great, 13 people. We'll give it another 30 seconds, 1 minute-ish. We'll start at around 6:05. Oh my god, that's such a shame to hear mistakes are costing you that. Okay, I'm gonna switch my tabs in a second. Yeah, let me move my microphone in front of my keyboard for you there. Cool. So I'll just change my tab really quick. Not that I'm really doing anything major, but I do want to just go over a bit of things. Cool. So, let me pull this up a bit bigger here so everyone can see. You know, I just put some quick notes. I know I want to do slides and stuff, but you know, we're all busy. We all got projects. So, you know, as you folks can see, welcome to this tutorial. You know, as you probably can see by my title, if you haven't met me yet, my name's Alan. I'm going into my 5th and final year of software engineering at Lassonde, and I've had a lot of time to work on my my development skills, through all my experience, you can see. So I've done lots of school projects, including, 4,000 level courses where, they're very project based. I've done a lot of hackathons, and I've, came out with, great prizes. As well, I've, had the ability to work at some different companies, including Coinbase, where I used Golang. And as well, I have my own startup named Radar, and our backend is primarily built in Golang. So today I want to kind of teach you folks a bit about what I know. And we're going to go through a tour of the Go programming language, which is accessible online, where you folks won't need to install anything yet. Then after we go through that tour, which I don't know how long it's going to take us today, we're going to go on how to install Go on your own computer. I'm going to cover a bit of how to use some of the Go tooling that comes out of the box for things like downloading modules, which if you've used JavaScript like NPM or Python like pip, how do you get, different imports in there. And then I'm going to show you folks how we can quickly spin up an HTTP REST API. And, if we even have more time, I'll show you folks how to, get it working with JSON, so you can get it working with a nice front end. So that's a little bit about what we're doing today. So if you folks want to learn anything or you have any questions, please post in the chat. I know there's a slight delay, so it might take a moment to get to me. Great. So we're going to switch over to this tour of Go. And so you folks can all access the tour of Go at this link in the chat. And so that is tour.golang.org, and the view I'm in is the list view. If you go to tour.golang.org, it'll take you here, which is where we're going to start today. So to cover a bit of information of what is the Go programming language, the Go programming language is a very succinct language that allows you to easily describe the ways that systems work. And the biggest benefit for this that most of you folks will find is in writing backends or even in writing desktop applications. Really, anytime where you want things to be done in a very systematic way, versus where you might want a bit more flexibility in choosing what you're doing, such as data processing. But I assure you that's going to come to Go soon. So Go was actually made by Google about 11 years ago to solve a lot of the challenges people had in writing both C, writing Java, and I guess you can say that Go takes the best of all of those together. So what I have for you today right now, what we're going to start with is called the Tour of Go. The Tour of Go uses something known as the Go Playground, where it's a sandbox where you can write and execute any Go code you want. And the Tour of Go uses the sandbox to basically show you all the concepts of Go that we're going to go through today. And so just to have a simple explanation, so everyone should open tour.golang.org. And you can see just by hitting the run button, you can run whatever is over here, which makes it a bit easier to learn without having to set up a whole IDE. It's available in lots of languages. You can download it offline. So you can see a bit more of the playground here. Just during the introduction, and then that's the first module of the tour. So looking at the tour overall, we can see that there goes into 3 main areas. There's the basics, which folks who are familiar to other programming languages might know a bit about already. And then as well, 2 things that are very unique in the way that Go works, which is its methods and interfaces, and then concurrency. The biggest thing you'll find from methods and interfaces is this is really what makes Go a great language, because you'll hear a lot in the community, there's only one way to do things, which kind of enforces to developers, and especially when you're working in a group, that you're doing things the right way. And then concurrency, which we're not going to go over today, is something really powerful in Go, which lets you handle things happening at the same time. So it's definitely something you might want to look at on your own, but it's not important for what we're going to do. So we're going to start at the first part of the tour of Go, which is packages. So for folks who've coming from other languages or who don't have programming experience at all, you might understand there might be a concept of bringing code in that isn't a part of your own program, and that's obviously done by importing code. The way code is separated in Go is in packages, which might be familiar if you use Java or other languages, and they're essentially also known as modules. So we can see that we have a packages.go over here. And in packages.go, we can see pretty easily that we have both funct and math brand. These are two packages that are being imported for this code to run. And the code that's being run is just using the funct package. It is print line. My favorite number is random integer, up to 10. And so you can see that this is pretty straightforward and makes it really easy to use Go code. When you're going to be using some modules later on in this tutorial, I'll show you how to actually download ones that are not hosted in the standard library, that is the code you already have downloaded, and how you can import people's code from places like GitHub. What's really great about Go is you don't need to publish your packages to any package repository like pip or npm, and rather just hosting your code on the internet and making it visible will be enough for people to import it, which is really great in spreading things out. So that's basically a bit of packages, which we're going to be using today for any time we want to print things or do math operations, for example. This slide just basically goes over, you can import things on separate lines, but the best way to do it is to use the import at the top over here, where you can just import multiple with brackets. As well, it's important to know how you export things. So similar to languages like Java, there is the concept of kind of private and public, things that can only be seen in the package and things that can't. And so the way things work in Go is when you capitalize a method, such as saying, function get, this function is visible outside, while function get with a lowercase is not visible outside. So if I were to import whatever I'm making, you can't see anything with a lowercase, which is kind of interesting because, in Java, we learn, put private for private, put public for, public. Rather in Go, it's a bit more idiomatic. It's uppercase for export, lowercase for don't export, makes things a bit easier, a bit less terminology. So when we see math.py, the reason it's, it would be a method that I was just making, yeah, if I asked. But if you see a math.py here, if I try to run it with pi, it won't work because you can see the errors cannot refer to an unexported name. So you have to refer to exported things, such as pi with a capital, because that's exported. And so that's important going forward, especially when we start talking about bringing in important other libraries, such as, Gorilla Mux that you might want to use, or Gin or Chi for your HTTP routers, GoLearn, the Go version of sklearn, whatever it is you want to do. So I see you're asking, Fayaz, is it a method? So Go actually has a bit more differentiating between functions and methods. And so methods are generally going to be things that pertain to a specific object. And we'll talk about what that really means later, or a specific type, rather. Functions are just general, functions you can call. And they're pretty simple, right? You kind of reverse of Java and other languages is you put the variable name first and then the type. And so anything that goes in the brackets of your function name, so if you have the function add, it takes in x and y, and it's going to return an integer type as well. Go is what's called a typed language, so you folks can see that we have to explicitly declare the types. With the generics that are coming in February, there are ways for saying something generic to come in. And so you return x plus y, which is also an int. So if you had 1 plus 1 or 42 and 13, like in the example, it'll return a single int. Pretty simple, and that's how you can make anything. So if we wanted to make a new function for subtraction, we can also do the format, which the tutorial will teach about in a second, where you can just write x comma y int. They're both ints. Luckily, we can just use them together. And same thing, we can return x minus y, right? And so if we run this, it'll run the add method, it'll add those. And if we run sub, it'll run sub. Pretty straightforward. And for folks who already know a bit about programming, this should come really simple to you. If you don't understand exactly what's going on, ask questions. I know we have an audience of lots of different types and backgrounds here, so I want to make sure we get everything. So like it says on the left side, notice the type comes after the variable name. So, if my variable is x, it comes int after, versus Java, which, would be more like int x. This is more like x int. Since each statement doesn't end with a semicolon, is Go space sensitive like Python. Go isn't space sensitive, but it does have its own compiler, which doesn't use look ahead, which is why you don't see the semicolons and stuff. So rather, you can just provide it the correct syntax, and it knows what to expect. So when I say return, it knows how to understand what comes after, and you don't need a semicolon to say it's the end. But there are times when a semicolon is still used in Go, and I'm sure we'll go over some examples later. But for certain things you might want to combine, or certain one-line statements, you do use a semicolon to force the compiler to say stop, or something's happening here essentially. But beyond that, there you don't really need it. So no semicolons, pretty simple. When I went back to coding Java for a few weeks ago, I kept making tons of mistakes because I forgot, semicolons everywhere because I just got so used to Go and no semicolons. So like I just said with the sub, you can put things that have the same type just after each other. So X, comma, Y are both ints. If you had multiple strings, if you do all sorts of things, it's a bit of what's called syntactic sugar. And so syntactic, I hope I spelled it right, sugar is just ways of making things seem nice, quick, easy for developers. You don't have to say what types are everything. It's an int, that's an int. You can see they're both ints without needing to look too deeply because there's X, comma, Y int. And as you see, this is the same method that ran before with how it worked. And functions in Go, which is really great, which is something really simple to me. I code in Go all the time now. I'm coding almost every day for my capstone project and my startup. One great thing about Go is it can return multiple results in a single function. So for folks who might have done some higher level Java programming, you might have had to make wrappers so you can return multiple things from a certain Java call. And Go is kind of the opposite, where you can make that wrapper type, but you can also just directly return multiple things. So if I'm swapping X and Y, obviously without pointers, you can return back string string. And instead of returning XY again, you return YX, and that swaps them, right? So if we ran, we can also, and the way we accept it, you can see, is with A, comma, B is swap on line 12. So it's pretty simple that you can also accept multiple things. And we're going to see why this is really important with Go's error handling, because errors come in together. So one return statement can return multiple results. And you'll see some more syntactic sugar in a second. But you can also do something like this, which is kind of weird, where you declare things early. And so it's a bit nice. So if we ran this, you can see that it's not going to let me do that because it's from the same thing. But if you run this, you can see it says world hello because we swapped it. And you can actually do things like, we'll see in a second, but you can do x0, y0. And if I actually said, x0 equals y, or and y0 equals x, this also works with using some unique stuff in Go, where you can name the receivers, assign them values, and then just return, and it knows that x0 is a string, and so it'll return just x0. I don't really recommend doing it that way, but just a little bit to see the syntactic sugar Go can offer. And so having multiple returns can be really powerful, especially when you want to handle some more complex logic. You don't have to worry about returning only one thing or creating a separate struct to be the return. You can just return multiple values, right? Which is great if you're just handling maybe a few different numbers at once. And so like I just mentioned, there are named return values. So in this one you have split, which will split a number the way it is splitting it. And you can see it returns X and Y, and you don't need to name anything. Funct is, the format package, essentially. So funct.println or format.println. There's also printf, there's also print, there's errorf, all sorts of things with funct. And it's great. And I'll show you folks how to actually read Go doc in a second. You think Java doc is ugly? I'll show you Go doc, and you'll be like, wow, this is really, Go is great. It's so simple, so user-friendly, makes really Java look like it was made in the 70s, not the 90s or 80s even. Cool. So you might be wondering, great, I can see how to use functions, but how do I declare my variables is maybe something you're wondering. So I'm sure a lot of you, have seen this kind of language before, where you can say, variable this is this type. Kind of in Java, you can say, private int I or whatever it is. Go, if you want to declare a variable outright, you say var, you give it the name, you give it the type, and you can declare multiple. One thing to know about Go is when you declare something as a variable, it's not like Java where things are nil, or rather null. It's what is actually called nil in Go, which is its 0 value. So you won't run into null pointer exceptions for not assigning a value to something, because when you declare something in Go, it just assumes it's the 0, right? So when we say var I, we're not going to get a null pointer because I hasn't been given a value. Rather, it's going to just be the 0 value. And with the Booleans, they're false, for default, and sorry, 0. Pretty straightforward, and it's an easy way to declare a variable. But this isn't actually how we normally declare variables in Go, because Go has a bit of a dynamic typing, which we'll talk about later. So to assign values, when you have a var explicit declaration, you can just give it a value. If this is a more global one for the package, or rather you want it in here, you can just put equals. And you can assign multiple at the same time, which is similar to other languages like Java. And you can just say, variable is this. One unique thing to be aware of, though, is because you're using the equal sign here, you don't actually need to say what the type is anymore because it can just assume the type, right? If you say this is equal to whatever, it can assume the type. Yes, you can explicitly say it, but you don't really save any time or effort. So it's useful just to leave things out, let the compiler handle it on its own, and figure out what you want. And if we run this, you can see I, J are 1 and 2, C, Python, Java, true, false, no, and that's exactly how it comes out. 1, 2, true, false, no, I, J, C, Python, Java. So pretty straightforward. If you folks have questions, let me know. If you folks are one of the people who are going to be viewing the recording of this, you can tag me in the Discord if you have any questions. So like I said, Go uses a dynamic kind of linker for its types. And with that in mind, you can explicitly declare a variable without doing something. And yeah, in Go, there's no dot equals FIAS, so you won't need to do that. Ghostly Mango are int primitive types. They are kind of primitive in a sense, but they're not in Java, where the reason Java has primitives and non-primitives because everything kind of comes from this object, but some things don't really come from object because the language is a bit weird. In Go, you don't really have to worry about that. So ints are just like any other type in Go. There isn't really that sense of primitive that you have in Java, where you can use arrays, and you have to put integer with a capital I because that's a non-primitive wrapper for a primitive type. Anyways, so this is really important, though, is shorthand variable declaration. So you can see that we can also just say k : equals 3 and Go, compiler looks at it, says k is an integer. Obviously, it's : equals 3, which is a number. I can say that, my name is, Alan. And if I do fums.println my name, it'll also, be able to do Alan. And it knows it's a string because you don't need to tell it it's a string when it, pretty clearly has the type over there. So you can see everything runs 1, 2, 3, true, false, no, Alan. We assigned everything with colon. We assigned with equals, : equals without the type. Tons of ways to do something in Java and Go, but the way we're going to be doing it most times when we write it is with the : equals, and that's because it's shorthand. It's easy. If you change what the end type is, it'll also change it. But the one thing to say is you only use : equals once because that's assigning a type. So you can't do my name, : equals, FIAS, because it's going to give us an error saying, no new variables because you can only assign it to new. But if I put equals, now it works because it's the same type. So just something to be aware of is that you only do the : equals once and not every time. So just like you were asking about, primitive types. So yeah, the basic types in Go, which are the types essentially that are built in, are Boolean, string, integers, unsigned integers. That means only positive numbers. Bytes, which is just an alias for an unsigned 8-bit type. A rune, which is a 32-bit, and is also what we use for Unicode characters. As well, we have floats, which in Go only has ints, uints, and floats. There's no double type, so you just use a float. And then as well, complex numbers. So these are the basic types in Go that you can always use to build things. But because of the nature of Go and being able to make all sorts of things in the standard library, there are a lot more types in the language you'll be working with. And when we go over interfaces, you'll see how types and interfaces create methods. So nothing too complex here, and you can just see, we go to tour shows us, bool, uint, and complex, 3 ways of assigning, false, moving, bit shifting down, and then as well, a complex square root from the complex package of math. One great thing about, printf in Go is with %t, you can always see a type, and %v will always show you the value. So I'll even show you that here, is that %t equals type, and then, %v equals value. You can always do %s equals string, but a lot of the time, realistically, you'll want to print out the value. It's the same as all other language. Print d is a digit, aka a number /int. Cool. And, f is a float. So you can see the way we print it out, that we have, bool, uint 64, and complex 128. So hopefully that makes sense, and you can see what the values of those types are. Pretty straightforward, and these are really building blocks for everything else that the standard library uses as well. Can you reassign it to another type? That's a great question. I'll jump back a bit to answer it. Can you do that? Well, let's see. My name equals 5. It won't work, actually, because you'll see that I cannot use 5 untyped int as type string. So once you set something to a type, you can't change that type. But similar to Java and some other languages, we'll look at how you can maybe use a parent or some sort of interface to define it, and then have sub things that can also work. And, I can just show you a quick example. Type, test interface. If I have a function, func, print x and then x. And then I basically make type, 1 as a struct. I know this is a bit over the head right now, but I'll just show you that I think the way that you can get 2 things, and you create the receiver funcs. So, you have, print, it takes in, let's say, x int, returns, sorry, int. X int, you don't even need to say x, and it returns, int. And then you basically make one for each of these. So you say, 1, and then you can make the same thing for 2. And I'll just quickly show you that it kind of, there is inheritance in Go, and this is why. So, if I make this var my name is of type test, and then I say my name, equals 1, and then my name equals 2, we're not actually going to get any errors. Yeah, 19 is the, get an issue, expected function, interface, name. Anyways, the idea is that, we have 2 types, 1 and 2, and, by fulfilling an interface, we can give things an interface like as the value. But we're going to go over that later, because that's way too complicated for right now. But something to think about is how we can manage inheritance. So like I mentioned earlier, everything declared without a value is given its 0 value except for pointers. Pointers can be nil, and you'll get a nil pointer reference dereference if you try and point at something which hasn't been declared. But for everything that's a value, it'll always be initialized at the 0 type. So ints are 0, booleans are false, strings are empty. And you can just run this, and we can clearly see that, everything without a value is assigned a 0 type, which is really useful to avoid errors. As well, Go has type conversions or type casting that you might have seen in other languages. So converting, numbers to floats is very useful, or whenever you need to say, okay, I have these integers, but now I want to divide them. I don't want to run into an integer division issue. And so, because if you try to do x, divided by y here, you'll see what will happen is that x divided by y, 3 divided by 4 is showing 0 because the 0.75 is truncated. But if we, were to declare things as floats, so, did float, 64, float 64, we can see the type conversion, similar to square rooting and stuff, lets us you know, do all sorts of ways to represent our decimal values. And so type conversions are really important, and you can type convert, you know, string and all that, things to string and all that. So it's pretty straightforward is type conversions. You can see the format here is you put the type you want to convert to and then the brackets. So instead of a function name, you just put the type you're trying to convert to, rather than, you know, typecasting, you know, saying something like this that you would do in Java. You know, you'd say, you know, x equals, you know, float y, right? That's how you do it in Java. And actually, I'll leave that here. And then, you know, in Go, you have x equals float, you know, y. And that's like, you know, the Go way of doing things, is that how you put them with the brackets. So there's also, you know, type inference. And so if you don't specify something exactly, it will infer it. And so like I've said, you know, you can just change the type with the colon equals operator. So, you know, if I change this to 1, 2, 3, it will run as a type of int. If I have this, it will just run as a type of string. So pretty easy. Maybe I did this with harp once, and that's why it says harp. I have no idea. Cool. Go also has constants like other languages, like pi, like whatever you want. A lot of the time, maybe you want to declare a port that's going to be constantly being used, so you can just declare a const there. And, you know, you'll see that pi will just be printed. Happy Pi Day, right? Const can also be done within a method, you know, const truth equals true. Pretty simple, pretty straightforward. I don't want to waste anyone's time, but if you have any questions, please ask and I'll go back and answer it. Cool beans. So next we have numeric constants. And these are just, you know, ways of having, you know, precision values. And so you can just do things like bit shift, basically. So you can see create a huge number by shifting 1 bit left 100 places, you know, creating right. Does Unicode work for strings out of the box? Michael asks. Yes, Unicode does work, and those are called runes. So really a string is, you know, an array of runes. And so you can type convert between a string and array of runes really easily. They're essentially the same thing. Will it have preset libraries? Go does have preset libraries, a standard library, which is pretty big and very powerful. So, you know, you can run this and you can kind of just see that constants don't need to be typed. They'll just assume whatever value it is, which, you know, can be really useful when you're dealing with bigger or smaller numbers, and you want to have some sort of shifting being done. How does string concatenation work? We're going to go look at strings in a second. And so let's actually go and we'll see. We're moving on now to I guess, the, where's this? So we're moving on to, okay, I guess flow controls. So there is, I guess there's no string one here. So there is string concatenation. I'll show you how it can be doing. We'll just do it in this example here. I'll just quickly show you some string concatenation, you know, hopefully I can comment things out. Actually, if I want to, if I have two strings, hello, world, that's totally valid. And you just use plus to add things and Go. It's not like, you know, Java or anything complex. You can just use plus. But similar to other languages, you know, you can use sprintf, which, you know, can do things like, you know, %s, hello, and then you can put like, you know, hello world. And sprintf, really what it does is it takes a format, right, printf, print format, but it returns a string, which is the s. So it's a string formatted. And so if I were to run this, it also prints hello world. So two ways to concatenate, with plus or with sprintf. But we'll get back onto loops. So I know folks have seen loops before. I'm sure this looks really familiar. The loop syntax is not hard in Go. But let's say we, you know, have a sum, which is 0, and we're going to count to 10 and add it kind of like almost, you know, addition factorial time. You know, they can be really simple. I is 0, I is less than 10, I plus plus add to sum. You run this straightforward, no issues. One thing to be aware of is you do not put the brackets here like you do in other languages. You just leave it empty, and Go is okay with that. The compiler is built to see for and to understand it's looking either for semicolons or for some other stuff. So if you're building a standard for loop, where you're counting up, all you have to do is just put your variables, your conditional, and then your change, the post statement. So the init statement, condition expression, and post statement, and you can actually see that right here, explaining a bit about the basics of a for loop. I'm sure folks have seen it before. Should be pretty simple. So we're going to move on so we can get to the meat of everything still. One thing I'll say is things can be optional. So you can not include the first part or the last part, but you still need to put the semicolon if you're trying to have the conditional or something. So you can see that this, counts to 1024. It just keeps adding some and doubling it every time. And so, 1024, 2 to the 8 or whatever, who knows? Not me. So pretty simple and straightforward for these loops. Go also has while, but Go doesn't actually have the word while. Go just has for. And so all you do is if you don't put semicolons, it's kind of a while loop where it's just the conditional. And so Go only has while, for each is also just for, no while is what I mean. And so you can see you run this also coming out at 1024 again. We can see that infinite loops also are just for, right? So if you do not put a condition at all, it's just going to keep looping. And so this, it says waiting for remote server. That's because it's not returning anything. It's timeout running program. It just kept running, not doing anything. Go's ifs are similar in the sense that same exact thing, just no brackets, right? You do not put the brackets in Go. You just put the condition and you're set out of the box. So, a square root, where if it's negative, you just flip the negative so it's on issue. And you can see, square root 2, square root 4. Or like this is, so put 2 and then put I, right? If you have the word negative 4. So pretty straightforward. If statements, nothing really new here. But Go does have a shorthand way of doing things. So like I said, there is use of semicolons outside of just certain statements. So we have math.power, put 2 to the 3, 2 to the 4, whatever it is. And we can also assign that to a value. And the kind of thing is, so if you combine it with an if statement and you use this if with a short statement kind of thing, you can say if v : equals math.pow, v less than lim, you can return v, otherwise you return your limit. And the reason you might want to do this in a lot of cases is you'll write things like, if error : equals method of, whatever, and then, error is not equal to nil, meaning you don't have an error, there is an error, you'll want to handle it. And so it's just a shorthand way of doing some things. So it's important to know, you'll see it in code, you'll use it sometimes, and you can see, that if you run this POW thing here, it will be able to give you 9, give you 20. Why is it 20? Because if it's less, you just return the limit, right? So just a bit of fancy way, hopefully not too confusing or going over anyone's head. Not the most important part of Go itself, but it's not. I wouldn't say it's like a ternary operator. I would say it's really just a shorthand way of doing things. I guess it's kind of similar to a ternary operator in a way, but it's a bit more verbose and it's easy to read. It works really well in Go's compiler, which is why it's like this, and it actually can be used in tons of ways. And so sometimes you'll want to have a method, you'll want to see the value and immediately check it, which is something we'll also look at maps and handling maps in Go, and pulling values out and seeing if they exist. Unlike Java, there aren't issues like that. Go also has else, pretty straightforward. If it's this, do this, else, do the else. The one thing I wanted to mention is this colon equals is called the walrus operator in many languages. So if we see, the walrus operator thing here, if you have v : equals math.pow, the v is actually scoped to the conditional block it's being called in. So if you tried to call v here, you would not get a value because it's only scoped to the conditional block itself. So kind of like some variables are scoped to the method or the function, or some are scoped to the package or globally. The ones that are called within the conditional are scoped to the conditional. And so, this really is doing almost the same thing, the else is being handled. But the whole point of this is that you can't use v here, and you also have else, which is, important to know about. Moving on. So looking at a quick exercise with loops and functions, computing the square root. I suggest you folks do it on your own. I don't want to waste your time, but, can you make a function to basically compute square roots on their own? I'm sure a lot of people in first year have written something special, and you can see that, these actually get the same thing with, square root your own function using this variable. I've done this before, and I've done this tutorial with other people. But you can see that, it's pretty awesome to use loops and functions together, as you've done in other languages, I am sure. Go also has switching of variables, which is really common. So, let's say you want to see what OS, someone's running on, you call runtime.go OS or goose, and you switch on it. So OS is this, then you say OS here, as in that's what you're going to look at, and then case of Darwin, Linux, or default, whatever. So you can see mine's going to say running on Linux. That's because the container that this is running on is Linux. My computer is Windows, but this is actually running on the Linux container. Switches are pretty useful if you only have a few separate things. If you want to handle case explicitly, if you're dealing with enumerated types, that is to say, let's say you have color, right? If you have a red car, increase insurance 10%. If you have a gray car, insurance down 10%. And, cases just let you deal with things exactly. Very similar to if statements, but they're more of a sequence. One thing to note is you do not need to write the break operator like you do in other languages. And it actually says that right here. The break statement is done automatically because, well, why write it after every time? And things are evaluated in order. So, today, tomorrow, 2 days, too far away. So Saturday is in too far away because that's more than today plus 1, more than today plus 2. And we're just using quickly to time.now.weekday to know which day it is. And so just a quick little thing on switch evaluation order is that they'll get checked in order, and if you move it, it's whatever default is the default for the switch. If you don't put a condition, then it will just look at your general variables. So it'll always switch on. So switch is true, so this will return good evening, because it's after 5 p.m. Pretty straightforward. So if you don't want to switch, you don't need to put a conditional. And just to contrast that, the reason we have this is to say that OS needs to be of a value to run, and switch time.Saturday will go and see what is if you take time.Saturday, it will switch on that, so to say. So it will be, are these equal is another way of saying it. So if you have an if statement where you have, if A equals B, you rather put switch A and then your case B. But you can also have C, D if you were to have if and else together. We're going to get to some fun stuff shortly. One thing to be aware of before we end this section is what's called defer. Defer is basically saying run this, but only when this method finishes. So if we defer world, it will, the compiler reads it, says I need to run funct.println world, but not yet. So it'll run hello, function ends, it runs world. Pretty straightforward, only called when the function itself ends. And then we can also stack the defers, and they're done in a last in, first out order. So, you'll see right now it'll go 9, 8, 7, 6, 5, 4, 3, 2, 1, because if you defer things, the most recent things that will deferred happen. And this is really useful in business use cases, especially because let's say you're handling credit card transactions and you defer a bunch of things to, say, okay, defer this if it went wrong, whatever. It'll kind of go backwards to fix your credit card transaction and kind of revert it with its deferred statements. Cool. And so that's the last one in kind of loops and some basic syntax. We still have one more to go before methods and interfaces, and that's when I can dive into a tutorial on how to actually use Go. But I just want to make sure people know the syntax. I know folks maybe might be a bit afraid to see pointers, but the truth is all your pointers basically mean is accessing memory directly. So if I declare two variables, I and j, and I will point to I, and you can actually see that's a pointer, %p, which is actually the pointer to I, or asterisk p will set I through the pointer. And this is the exact same where you can use the pointer with the asterisk, or you can get the pointer with an ampersand. So line 13. Oh, oops, I added this. I smacked an equal sign by accident. And so you can see, yep, this is int. You can see that this is 21. Let's add this backslash on here. So you can see that this is a type of a pointer to an int. This is the number 21. You can see that this is 73, which is 2701 divided by 37. Pretty straightforward. Important to know pointers if you start dealing with servers. Now here's something really interesting that I want to show you folks for my folks who are still here and my folks who are going to be watching later. Structs are a critical part of programming in Go and of programming in general, because structs are what's going to define types that are not, default in Go or libraries you're importing. So a very simple example can be done with cars or shapes, or just a simple vertex, right? So we can define a vertex XY, right? Let's say we were trying, draw a shape, right? We can make multiple vertexes with XY coordinates on a Cartesian plane. And the type vertex takes an X, is an X int and a Y int. The way you declare things in Go are pretty straightforward. You just say vertex 1, 2 will make that as the constructor. You do not need to make any fancy constructor in Go. You just say the type and you put in the things. You can be more explicit. You can say X and you can say Y. And when you run this, it will always just print the values like that. If you ever want to see exactly what is the things being printed, you can always do % plus V like that. Go is not fully object-oriented, but you can use it in an object-oriented way, which is nice and useful. And as you can see, I'm doing printf plus V. So the difference is if I just run V, it'll print 1, 2. If I do plus V, it actually prints out the labels for the type. And so you can see X is 1, Y is 2. Pretty useful for debugging, if I say so myself. Sometimes you don't want to run through the debugger. And so straightforward, this is what a struct is, and you can do a lot just with structs in Go. And kind of like Java, as if things were public, you can just access them directly with .x, and that will access it. So we can see that we're assigning it to. I'm just going to print this out above too. We can see that we are setting x to 1. Then we're setting it to 4. And you can see it reflected, right? 1 and 4. Pretty straightforward, and it's great to have. You can also make pointers to a struct, which can be pretty simple. And so if I run this, you're going to get on ANV, the pointer to this is, I guess 1 million. And you can set, p.x like that. And so for folks who maybe have done 2031 or 2032 at York, they might, be used to the syntax where it's like this on line 13, where you have to, point to the pointer, access the pointer, and then assign values. In Go, it knows what you're trying to do. It knows the pointer does not have something named X. So if you do pointer.x, it says, oh, okay, just do that. Just assign what it's trying to point to. Of course, you can do that. It's going to do the same thing. But why waste the effort? And that's why Go works for developers, not against them. And you can actually also do all sorts of things like the literals I showed you. So you can define 1, 2. You can only define X, and then the Y will be the 0 value. You can define nothing. Everything's a 0 value. You can define them as pointers, which are really useful for servers. and we can just print, see what v1, 2, 3 come out as, and you can see 1, 2 takes 1, 2. We can see the that P is a vertex of a pointer 1, 2. We can see that V2 is explicitly X, and Y takes the 0 value, and X and Y both take 0 value. Really simple, no constructors to deal with. It takes the 0 value. Why would we teach this in our school? When why shouldn't we teach this, opposed to Java? You have to tell me, because to be quite honest, Java really is working against our students. And so this is pretty straightforward and really forgiving, built for ease. And I think you folks will love it if you develop with it. And I hope you folks will have the chance to work in it. And also one quick thing to note is you can also declare multiple things of the same type in a struct, just like you do anywhere else. That's, again, the Go compiler working for it. It's the same code that, uses the functions and knows that it's the same type there. So it will look for the type, after if it's not specified. Awesome. So we'll move on once again, and we'll start looking at arrays. This is one of the biggest things people wonder about when, they're starting to program, is how can I make lists of things? In Go, you can declare arrays all sorts of ways. And you can declare them, with the capacity. So, if I say A is 2-string, then it will basically be an array that can hold 2 strings. Go indexing starts at 0. So, you would put, 0 equals hello, 1 is world, and then you can print them out, and, you'll get hello world. And you can also print it together. You'll get hello world, which is the array itself. And if you made an array of 6 numbers called the first 6 primes, essentially, you can also print that, and it'll just print the array out. Nice and easy. Don't need any dot to string. Don't need to cast it to anything. It'll just print it out and print its values. Array length is a part of the type, so you can't resize it. But I will show you that you actually can resize arrays very easily in Go. So this is more called slices than anything. So if we have primes of 6 numbers, we can look at primes 0 to 6, and that will print out everything. What if we look at prime 1, 2, 5? What do you think that will show? That will actually go 1, 2, 3 up to 5, and we can get just a part of an array. It's called a slice of an array, which is really useful to work with. If you don't put anything at the front, it'll take everything up until 5. And if you put only something at the front, like 3, it'll start only from the 3rd element forward, so 7, 11, 13. Pretty easy way to deal with arrays. Works on all types. There's no array list like in Java. Every array is the same, or every slice is the same. And really, slices are just references to arrays. So, John, Paul, George, Ringo are Beatles. We can say the first, 3 names, the last 3 names. We can change a slice, and we'll actually see how it affects it, because it's a reference. So, we get all 4 of them because we print all the names. So, and we get, 0 to 2. So it stops at the 2nd. So John, Paul, we get Paul, George is 1, 3, starting at element 1 and before element 3. And then when we print out, when we set B to 0, which is really, if we look at B was printed Paul, if we set Paul to XXX, that will change all. It doesn't just change the array, or just the slice, it changes the underlying array that the slice is referencing. Slices are kind of like windows looking at an array. And so when you do modify that slice, you do modify the underlying array, which will affect other slices. And that you can copy arrays if that's your worry. You can also make a slice literal is like an array, but without a length. So, if you just say 2, 3, 5, 7, 11, 13 goes, like, you don't need to tell me there's 6 in there. I can count. Thank you very much. And that's exactly what it does, all of here. You can also define struct. I don't know if this is how it looked default, but this is that you can also define structs in line. So if you wanted to make an array of custom types, which is really useful for data science, you can do it in line. And so, if I run this, you'll see 2, 3, 4, 5, 11, 13. You'll see, true, false, true, false, true, false, whatever. And you can see all these tuples of this struct that is defined here. If for some reason this maybe looks a bit weird, I can call this new type, and let's say I want to put new type. I go type, I go type, new type, struct. Just go like that. And maybe you'll see that I define my type separately. It still works. It's the exact same thing, but sometimes you want to declare it in line. Might be so you're writing a test and have the test cases that you're only referencing one place, and you can just do it there. Go knows what's there. It has its own, great compiler. And just like I mentioned about bounds, if you put the nothing in front, it goes from the beginning. If you put nothing in the end, it goes to the end. And so it's pretty simple. The one thing you'll see here is this is our slice. S is slice 1 to 4. Then we bring it down even more. We can't really push it around more than that. We can try doing, 3, and that will actually extend it out back again. Just like I said, it's a window. But if you try going to -1 here, this is an error because you can't go -1 in arrays. Index must be non-negative. So what I'm trying to just quickly point out is that you can open arrays back forward if you bring it slice. If you minimize your slice and then make it big again, that works. But if you do it to the front, you can't go back there. So it's just about being a bit strategic when handling that. Cool beans, slice length and capacity. So this is what I was talking about, is the capacity. So if you reduce certain things, it might be be unable to access. So that's the difference between length and a capacity, right? If my capacity is like 10, but my length is 6, though there are 4 things that I'm not fully accessing, and we can just take a quick look at what that looks like. Is that if this is a 0 length and then we extend its length and then drop values, it totally works. So you can see that we make it nothing, we extend it back out a bit, and we cut out the first 2 values. Cool beans. Slices can also be nil, so an empty slice, and the slice will be valued to nil. So if you wanted to fix this, you have to do that, and this won't be a nil slice. What would I do? Expected end of statement 6.3. Did I run this before I hit that? I don't even know what happened. Sometimes my brain's too big for my own good. But if I have 1 here, the slice is not nil. I don't know what's happening. Expected at end of statement. What do you want from me? All right, it's okay. Another way you can make your slices is with make, and that is pretty straightforward. It first takes a length, and additionally, if you want, you can put a capacity, and so you can put make int of length 0 but capacity 5, or you can just do a length of 5. I know that this part gets a bit boring and more difficult, but it's important to know about length and capacity a little bit, just because people will make errors and not know where they come from. So you can see that if you have 5, length of 5, capacity 5, but if I specify length of 0 and capacity 5, then it doesn't print it. If I have a length but I can extend it out, which is C, I extend out my 0 length 5 capacity to 2. I can extend it out even more. Works perfectly fine. By capacity, I basically mean, let's say you had a train, right? And your train, had a capacity of, 5 train cars, right? But the amount of people you're only putting it into was 2, right? 2 of 5 train cars. 2 is the length of the train that's being used, I guess, and 5 is the capacity. It's really the maximum. So the idea is that you might have a length and capacity mismatch if you're trying to, shrink, or if you're trying to make a slice that only looks at part of an array, then your length of that would be less than the overall capacity of the array. It's not very useful in day-to-day programming, but it's something to be aware of. Cool. Awesome. So slices can also be slices of slices. So, we see, a 2D array here. So basically an array of strings. And we can change, specific ones. And, this makes like a little X and O board, just by the way it works, right? And so if I were to, add, board 0, 1 equals X, you can see that this actually becomes a win. And so 2D arrays or slices of slices are really useful when you want to represent things. So, let's say I had, list of grades. It could be, an array of grades. And, maybe that's because I'm trying to represent, maybe list a list of ints rather. And so, maybe I want to have like, a 60, 40, these are students, right? And then, int is 30, 55. So the main idea is that, like, you might want to have 2D arrays at some point. And so you can do that in Go just like any other language. It's going to say error, not you declared but not used. One quick thing to say in Go is if you declare something, you have to use it, which is pretty interesting. So if you declare something, you have to use it, otherwise delete it. And yeah, no new variables. So if you for some reason don't, just quickly replace it with an underscore and it'll still run. What up, my people? So we're just doing the tour of Go. So you can, this is really what I want to get to in this area thing, and in this area of appending a slice. So, like I said, when you declare an array, it is given a specific length and size. But what you can do is you can append things to it. So we have S is our slice. We're going to print it out and see nothing's there. We're going to add a 0, and we're going to now see there's a 0. Then we're going to add a 1, and then we can even add multiple. So you can see pretty straightforward that we can print that it'll increase its capacity and its length every time. Let's also look at one more thing I'll say. That let's say S is append. You give it S as the base, and you want to give it ints 1, 2, 3. Again, and you can say print slice S. This is going to give us an error, because you're only supposed to give values, right? So because you're only supposed to give it values there. So cannot use int, type int as int. What you can do to get around this is just ... and it'll actually add the array, because it spreads it out. It turns it into separate ints. Why Go? We'll go over that later. We've done a lot of talking about the unique things about what makes Go easier to work with. Why it's easier to deal with types, why you'll run into less errors, and we'll go into some of the tooling benefits of Go and why it's used a lot in systems design in all of the world's biggest companies. A language made by Google, now used by tons of others, from Twitch to Coinbase to Uber to Netflix to every company now relies on Go for their critical infrastructure. And I'll show you folks why that's really useful. So maybe some of you folks came from languages as well with for each loops. What you can do is you can for each in Go, and the way is using this range keyword. Range basically says, let's take this array and let's go for each element in it. So I is the number element, so element 0, 1, 2, and v is the value of that element. And so we can see, if we make a power, 2 to the 0 is 1, 2 to the 1 is 1, 2 to the 2 is 4, 2 to the 3 is 8, 2 to the 4 is 16, etc. And we can actually just quickly represent that here. We print out 2 to a power of equals, and that's for each. So that way you don't need to build out a big loop going through every index. This way we can just for each and use that. And let's say you don't need that I, right? You can just skip over the value, right? Let's say you have an array of students, an array of cars, whatever it is, and you just want to go over all of them, add them, run something, whatever. Just put an underscore if you don't need to use something in Go. Because like I said, this runs, but if I assign I and don't use I, then it's going to say I declared but not used. So you just need to make sure you don't put anything there. And now we can print out all the values. And basically, this is bit shifting, one move the bit one down. Or this is basically saying create a 10 length array and shift it down each time from 1. Rust is great language for embedded systems. A lot of things are written in Go and Rust together. Rust is able to handle things really quickly, but is a bit tougher. Go handles systems really well, super easy to read. Using tools like gRPC, you can actually run them in tandem. Cool. So implement pick, it should return a slice of length dy. Each element is a slice of dx 8-bit unsigned integers. When you run the program, it will display a picture. This is great. I want you folks, you can do it on your own. We only have about an hour left, and I want to make sure we can finish our methods and interfaces section so we can go into making an API. So doesn't work. Let's make it work on your own time. The next thing is maps. I'm sure a lot of you has used maps or hash maps in other languages, and that's basically saying, you know, how do I give something certain values? So let's go back to our vertex we talked about before with latitude and longitude this time, right? So instead of x, y, right? Let's say I want to make some sort of geographic thing. I would say, you know, make my map of a map to string to vertex, or var m map string vertex. And what I'm able to do is I first have to declare my map. So make map string vertex. And then you can just assign it anything. So Bell Labs equals vertex. Pretty straightforward. You run this, and it prints it out. Really simple, really straightforward. And you can really make this for anything, right? So, you know, we can make our own example, right? String int. And, you know, it's person to followers, right? And, you know, you can say that, you know, Alan has, you know, 100 followers, right? And you can say that Fayaz has, you know, 5 followers. So, you know, if I run, let's call this M again because I don't want to change everything. If we see M Allen, and then we see, and then M Fayaz, and we run this. Can I use vertex? If we run this, first time works, we can see Alan has 100, Fayaz has 5. Really easy to use maps. This is simpler than most languages, definitely simpler than any typed language for sure. So even though Python, you can kind of make it, it doesn't really have types. Yeah, cool. So, and your maps can also be literals, that is, assign things at the beginning of the map. So, you know, Bell Labs, Google locations, and you can just print out the map. And the maps print out really nicely without any formatting needed. You see map, Bell Labs, map, Google. Really useful, really starting to get into the things that make Go a useful application, because maps are going to be used in all sorts of things. I do my leak coding Go, and maps are super easy to use, much easier than Java, that's for sure. Cool. And so you can see that once you declare vertex, this will be easier to see this way. This is pretty long. You're declaring vertex every time here, but we already know it's going to take in a vertex. So you can omit it and just put the curly braces, and it knows that you're making a vertex. Runs super simply. And this works with any types, really complex types and such. You can totally omit the name and just put in your map. Maps can be easily mutated by doing anything. One important thing is, what if you try and retrieve something from your map that doesn't really exist at all? Well, the way you do that is the same way you kind of get a value. You also add a second thing, which is OK. And if things are OK, then it will be OK. True. If it's not true, false, then things were not in the map. So we can see our map. We have answer. We're going to get the value, and if it's OK. We don't have an element named answer in our map, so it won't be OK. But then we'll assign it, and it will be fine. We'll assign it, it'll be fine. And then if we, you know, check the OK again, we'll see it's true. We can also delete from maps by passing the map name and the key we want to delete a value for, and we can check it again. So let's run it and quickly see how this works. So as you can see, pretty straightforward. The value is the 0 value for an int, and present is false. Then we get value 42 from here, value 48, and we can also see present is true this time. We delete answer from map. We print out the value of map, and it's 0. And if we check OK again, it's false, because it's not OK. It's not in the map anymore. Pretty straightforward. So, you know, this would be to develop, implement word count, return a map that counts each word in the string S. And so the idea is that if you want to, count the number of letters, right? So if you have some sort of leak code problem where you need to count a number of things, maps are really useful for that. Better than arrays, because you can store it to strings or numbers, right? See what happens twice, like two sum, right, or three sum. Really important to make use of it. And so, we can say, that well, just to run through a quick example for you, if we say m is make map, string to int, right? Then we say for letter in the range of string, right? We can say that m letter plus plus, because it's an int, and we can just say return m. There's its own tester. Cannot use letter type rune. Okay, great, thank you. The string fail. Okay, because it worked whatever this way. Oh, this was return a map that counts each word in the string. I don't even know what that means. The WC test runs. I don't even know where that is. Well, I checked every letter. I don't know. It's supposed to do every word. I guess iterate over the words in the string. You can do string.split. Let's see if I reset this. Yeah. Leak code. So yeah, you can see this one fails because you want to split this up. So yeah, if you want to count the letters, you do what I did. I didn't read the question fully because I'm rushing through this because we only have 45 minutes left. So you can also use functions in Go as values, which is a bit more of an advanced topic. But let's say you wanted just a function that takes in a function and returns the results, right? So we have function compute takes in a function which takes in float 64 and returns float 64 and returns a float 64. And then return just the function on 3 and 4. If we declare a variable named hypot, as in hypotenuse, and its value is a function itself of taking an xy, returning a float 64, returning float 64, we can actually print hypot 512, and we can also run compute hypot. And the reason we do that is because this returns the function running with 3 and 4. So consider the case where you know what needs to go into the function, but you don't know the function itself. Well, taking in a function as a variable for your function itself is really useful in certain cases. And we can see that we can also pass a function like map.pow, and it will power those numbers of 3 to the 4. And so, of course, our hypotenuse of 5 and 12 is 13, our Pythagorean triples that I'm sure everyone knows. We can also run the hypotenuse of 3 and 4, which is 5, again, 3, 4, 5, as a Pythagorean triple, and we can see 3 to the 4. And the main thing we're doing is we're passing 3, 4 always, which is really useful. And we can always do things like this, right? We can always do, x, y is int, and so compute takes in more numbers, right? So compute hypot 3, 4, compute this to, 8, and this is whoops, and I should probably take x, y. This way, you can kind of generalize a certain call to take a function. Cannot use x. Okay, and these need to be float 64s, right? So generic soon. We'll fix this, but you can see that we can run this with different numbers, taking an x, y, but we also take in the function we're running. So it can be a bit convoluted to some. Initially, you'll all understand why it's valuable. When you start dealing with more complex algorithms, being like, okay, I need to run different sorts depending on certain things. Here's my array. I'm going to add, compute sort, right? And I'm going to pass it a function, which is the sorting function. Because maybe I have different sorts I want to run in different cases. And that's really what I'm choosing. I'm trying to choose a function to pass to run something with. Functions can also be what's called a closure, meaning that you can reference things from outside of the body. So you'll see pretty interestingly here, we have a function adder, which returns which itself returns a function int, which returns an int. I know it's a bit weird to look at. Maybe if I kind of put some brackets here, you'll understand. Adder doesn't take anything in. It returns a function which takes in an int and returns an int. So you might say, why would you want to do that? That's because you want to maybe run you want to assign something to be some sort of variable, and you never want to really have to you want to kind of maybe run it after in a way to say it. So, I'm making some sort of function which I want to run all sorts of times with different variables. I'm going to assign that to variables itself, and then I can run it later. So let's see how it works, just generally. We can see that our adder is literally just an adder where it takes the previous number and adds it each time. So sum plus x. And so, you get 1, 3, 6, 15, because, 1 plus 2 plus 3. And the way it's working is it's saving sum every time. So maybe to reiterate, what it's trying to do is adder has a value named sum in it. And every time I'm calling it, it returns a function where it adds x to sum. And if I'm adding every time 1, 2, 3, 4, it's adding it to sum over here, despite the fact that it's never really taking in anything beyond just being a function. Pretty complicated to think of at first, but I assure you again, there are reasons why you might want something like this to use a closure. And generally, it is going to be a case where you want to have some sort of variable outside the scope of a function you're running. And so that's why you use it. When you need to use it, I'm sure you'll think of it. But until then, it'll be a bit vague. You can also run Fibonacci as a closure, right? If you have like, sum colon equals 0, and you take in an int, right? And you, kind of add sum to itself each time, right? You say you return, func int of like, sum plus equals sum, right? And you should return. So, if you do something like this, you're keeping track of, you're really keeping track here. And sorry, I guess it would start at 0 plus equals, I don't know, it's supposed to be 1 though. Anyways, this is doubling it, I guess. I don't even know how to do this right now because it's going to return 0. But pretty useful stuff, believe me. Yeah. So that's basically the module on using loops, on using conditionals, and then using struct slices and maps. So now we're going to get to the last part before we go into some of the more hands-on making an API is methods and interfaces, which is the most important part of the Go language, really. So we've gone over types and we've gone over functions. We have our type we've looked at before named vertex, and we have our functions, like one that's being defined as absolute here. We have something new that you folks might not be noticing, but it is this thing called a receiver. So before the function name, after the word function, is a type, which is v vertex, and it returns a float 64. The reason why we have the v in front is not because we are edgy, but it's because it's going to serve a value. And that is basically saying we're not just declaring a function named absolute. We're creating a method of vertex named absolute. And so if we run this, we can see, it's going to give us, the square root of, let's say, of like the hypotenuse, essentially, right? It's going to give us the hypotenuse 3, 4, 5, or Pythagorean triple. But, you can see that this can work, if I put v vertex here and I run abs of v, it'll give me the same result. So why are we really doing this? And it's everything to do with what I'm about to show you called interfaces. And so let's take a look. Okay, like I just said, you can run them here. It's just methods are just a function with a receiver argument, and the receiver is the thing in front. And you can declare a method on non-struct types. So, that is really anything can have something given. So, you can call, if you say my float is this, and you want to compare something, you can do it. I'm not going to read too much into it, so we can move on. You can also have a pointer receiver. which can be important if you're dealing with pointers, especially I'm using pointers a lot when I'm using servers. And so with that in mind, when you have scale 10 and it takes in a pointer, it's going to actually scale that by 10. And the importance might be, is if I want to do add, if I want to actually do something, the other way of doing this, right, would have to be saying, scale the vertex f float 64, and you'd have to return the new vertex, which is kind of annoying, right? So to actually change the vertex itself, we use a pointer. And by making it a receiver, it makes it very easy to see that we scale it by a factor of 10. And so, just run it. You can see 50, right? Because we scale it by 10. Pretty straightforward, but it's all to do with this little asterisk and this pointer here. So it's an important thing to be aware of, because you'll be writing it you'll be writing Go code at some point. You'll be like, why isn't this, you remove this. Why isn't this scaling it? Why isn't this scaling it? Because, it's all this is happening within the scope. It's not actually modifying it. So the pointer will actually say modify what we're referencing and deal with what we're referencing, not just the value we're passing. Cool beans, cool beans. Awesome. So on top of that, we have, like I said, you can put it there and it'll just run. But on top of that, we have interfaces, which I believe will be coming up. Oh, pointer in direction. So you might need to do an ampersand. So if you basically have this scale function, right, you need to pass vertex with an ampersand to make sure it's the actual one you're trying to pass. Pretty straightforward. If you don't want to put the ampersand there, then you should declare vertex with the ampersand, and that'll make it a pointer. Nothing too important right now. So interface. So this is what I want to get to. So we have something absoluter, or ABSer for short. And we're going to make this an interface. So Go has two big things, structs and interfaces. When structs and interfaces come together, they get to create, an interface type almost. And it's basically saying that I am agreeing that as, an ABSer, I will always have implement the ABS function with my receiver type. And the benefit of that is, of course, inheritance, kind of, because you can refer to something by its interface rather than its actual struct type. So if you have multiple types of vehicles that all have a .drive function, as long as you say interface vehicle, then you're able, with a function named drive, right? So if I say vehicle with the function drive, that will always mean that I am able to define what a vehicle is. And it's the same with this ABSer, right? And so you can declare things by an interface type. And as long as something like my float implements ABS with the receiver and vertex, implements ABS with the receiver, then those are able to be ABSers. So this is something that Steve was asking, or someone was asking earlier, if things can be changed. I think it was maybe O actually asking this. So this can be both a my float and a vertex, because really A is underlyingly an ABSer. And so when we run this, we can see it changes. But we actually see this as an error, because this needs to be ampersand, because only the pointer to vertex has it. So if we comment this out, we can see it totally works. And we're going to be looking at why this is important in our server and in our data layer later on. Cool beans. So things are implemented implicitly. And what that basically means is that Go links it on its own. In Java, you have to say inherits or implements, all of these different confusing words. In Go, you just do it, and the compiler says, dog, I already clearly see this implemented. Don't even trip. So it's the same thing here. So if I have an I interface that takes an M that returns nothing, and I have a type T, which is of type string, this method for T called M implements, the I interface I, right? This is I for interface, M for method, T for type, S for string. So because the type has the method, then it fulfills the interface. So when you say I of the type takes in the string, it totally works because it says dog, I see that your type T implements interface I because it is method M. A lot to maybe grasp at once, but is really important because, maybe I want to define, T2, and maybe it's going to be, print.line 2, right? And so I do this, and then maybe I say, okay, now I equals T2 OMG I dot M. The unique thing that's going to happen here is that my mouse is really slow all of a sudden. At TM redeclared in this. Oh, whoops. So this needs to be T2. My mouse is just being really weird right now. Cool. All right. Hopefully my mouse is going to work with me now. So you can see that this will actually print the 2 OMG because we've implemented a new type, and so you can call .m on both of them, kind of like in Java with inherited types or interfaces in Java. Hopefully that didn't sound too bad in your microphones. I just need to make my mouse work a bit better right now. And so you can see interfaces are for the specific values. And so we can use describe to see how things are. Describe is a function. And so, we describe I, and we can see it's ampersand, hello, and it's of type T, which will give you the value and the type. So it's basically describe will give you the tuple. We're going to get through this super quick. I want to show you some really cool stuff. So interface values with nil underlying values. Pretty straightforward that if the value itself is nil, then you might run into an error. So you might need to use what's called nil receiver. So you check, if T equals nil, basically deal with nil with the T equals nil check. Because if you don't do that, then it will print an error, a nil reference, dereference. Cool. One thing that's important to note is if you think of interface as a way of describing something in Go and describing its methods, then the interface with the curly braces that has no functions inside it applies to everything in Go, which is super interesting to think about, that all these types, every type, kind of like everything in Java is an object, everything in Go is an empty interface because everything has at least 0 methods, right? Because everything can't have negative methods, can't have no methods. Well, it does have no methods if it fulfills the empty interface. Might be hard to think about, but if I'm trying to declare something, interface or type I interface, right? If it doesn't take anything in, if there's no functions in here, of like M like earlier, if there's nothing there, then everything fulfills that interface because it's all nothing. I know it might not be easy to understand right now, but if you hear it now, it'll seep into your knowledge later. And so if we say variable I is an interface, we describe I, we see it's nil because the interface doesn't even have a value itself. We say I is 42, it's now an int. We say I is hello. That's basically saying this variable can be anything. And so more to what O was asking earlier, can it be another data type? Yes, but only if the underlying type is the same, such as interface. Cool. You can also do type assertions. So, let's say var I is an interface named hello. It's not actually a string yet. It's an interface still. But we can make it a string, right, by putting .string. We can check if that type assertion is OK with OK. And we can see when it's OK and when it's not OK. And if we do a type assertion but don't check OK, it will panic if it does not work. Let's run it. So you can see hello, it prints. We can see hello true because it's an OK assertion. We say this is F0 because it takes the float 64 0 value. And OK is false because it's not a float 64. And if we try to make it a float 64 without the OK check, it panics. Pretty straightforward in type assertions using interfaces, something we're going to see less when generics are implemented in February. We as well have type switches, which is to say, take in v and get its type. If it's an int, do this. If it's a string, do this, which might be really useful if you're dealing with all sorts of data types coming in a stream and you're saying, okay, this is an int, do that. This is a string, do that. And so, you can run this and you'll see that do 21, hello, true. Twice 21 is 42 because it's an int. Twice %v is %v times v times 2. We see that, our string is, bytes long with length of v. And we can also see default. I don't know about type bool because we haven't coded anything for it. So just a really simple way to say, use a type assertion with a switch statement to do what's called type switching. Really useful when you're dealing with lots of different types. So in the Go standard library, with its huge standard library, is interfaces. So Go, to make sure people can implement all sorts of things, especially when it comes to file reading and writing, they define a lot of things by interfaces. And one of the most common interfaces that everything has is stringer. And stringer just basically says it implements a dot string method. How do you print something to string? And so whenever you would call something, when you call print line, it's going to try and use the stringer method. And so if we have person, right, and we give it the string method, then instead of just printing, right, if I don't have, let's say, if I call the string 1, right, this will print out the values itself, right? Arthur Dent, 42, Zaphod Beeblebrox, 9001, right? This will just print them out. But if it fulfills stringer, if it fulfills the interface, the Go standard library already says, oh, this implements stringer. I'm going to use stringer. And it says Arthur Dent, 42 years. Zaphod Beeblebrox, 9001 years. So pretty useful way for using things with the standard library, which I'm going to show you is really useful for our net HTTP standard library, because the interfaces there have allowed so much to be developed that integrates directly into the standard library using, all these different interfaces that are defined for networking and HTTP and incoming and outgoing requests. So, if you want to make a string method, give it stringer, right? So if we run this right now, you get this because it's an array of 4 numbers, right? So to make like a stringer method, we'd say, func, take in, I don't know, let's say IPADDR, and we call, string, return string, and we say, return func.printf, and we say, %d, 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 and then, it's going to be I0, I1, I1, I2, I3, and we run this now. Undefined string. Oh boy, where did I do that? Line 8. Oops, I spelled string wrong. All right, there you go. If we do it now, want too many things to return. Int error 9, line 9. How is this returning an int? Coding's not always easy. Wish I got, so you say I got on the first try. This tutorial is way too big to get everything right. Oh, I see why I'm so stupid sometimes. This should be sprintf. So return sprintf. Great, and we can see that we actually get the different values based on our stringer that we created, because it implements stringer, the default library, the standard library knows what stringer is and leverages stringer to print it out nicely. There's also the error interface, where it has a function named error, which will return a string. And so, we can define custom ways of representing the error interface, which can be really useful. That, let's say, my error is when time what, and my error is has a function named error, then if I say return, my error, and I run something, and if error not equal nil, because that's how life works, we can just implement our own type of error response, which can be really useful using interfaces. Another important one, like I think I mentioned, is the reader interface. So IO reader represents reading a stream of data, which can be really useful if you're opening a file, if you're trying to read, some information that's coming in from, a data stream or something. So strings.newReader, hello reader is itself a reader, which will read a string, a new string. We can just say, for read, if, error is that end of file, we can break. And the thing is here that we'll just read it piece by piece, right? So, we'll read it in different bytes. And so, 8, we get all of these Unicodes, which is, hello R. And then we get another 6 eater, and then it's end of file, so it breaks. And so the idea is that read will just read in, an array of, here we have a 8-byte buffer. B is for buffer. We're taking an 8 at a time, and we're reading through it. And so if I would make this, 4, we can actually see that this is going to read in 4, hell, O, comma, space R. And so our buffer is able to read things. And because of the IO reader package, this is really flexible because we can make our own custom data types that can implement reader. And that we can basically make a way to consume it at any rate we want, byte by byte. And again, here you can see, add a read method to my reader. We only have 37 minutes left, raw 13 reader. You can as well see images for an image interface. Very easy, allow you to print out things. It's really nice if you want to do some image manipulation. I see we only have 25 minutes, so I'm just trying to finish up here. Congratulations. So the next thing is concurrency, which we're not going to go through today, but it's basically saying, can we basically run things all together? We actually can run things concurrently, which is through threading. So next thing I'm going to do is I'm going to just open up VS Code here, and we're going to get to doing some other Go stuff. My mouse is not working with me right now. Cool. So let me just get this running. Cool beans. Okay, I'm going to plug in another mouse I have. Sometimes it just ain't working with you. Gotta change on the fly. Alrighty. Cool beans. Got another mouse now. So let me change my share screen, and we're going to go to VS Code. Great. We're going to new file. We're going to maybe make one. We're going to save it somewhere random. We'll just make it in my dev folder. Great. And we're going to just save, main.go. So let's start working with Go on our own. So for our folks who haven't used Go in the past, you can download Go really easily at docs.golang.com, I think, and that'll bring or golang.org. And if you go to golang.org, you'll just be prompted to download. So, if you go to golang.org, and you can yourself download the Go compiler. Let's take a look today at how we can build a. I don't use VS Code too much, as you can tell. I usually use Golang, but we're going to today build an HTTP REST API. So in Go, all of our things start with package, main, and we're going to have in a func, and we're going to call it main. We're just going to test this out. We're going to say func.println hello world. See if it adds this. No. Great. You know. So, you know, Golang is lit. I might have to switch to it if I'm getting too much of a headache. Import func, right, and cd ///dev/ and let's go mod init. Let's call this main. Cool. And so now we can see we have open folder, select folder. Great. Save that. Open the folder. Okay, now we have our Go mod here, which is what we want. Cool. And we have the func. So, so if we run go run dot, we can see it prints hello world. So the next thing we're going to do is we're going to pull out, we're going to look at how to make an HTTP server. So I'm going to share a resource in chat really quickly that I've saved here for everyone to use, and it's called Go Web Examples. And so anytime you are in a hackathon, you need some things, you go to Go Web Examples, and you'll probably find kind of what you're looking for. And so the first thing you want to run, that we're going to use today is we're going to basically want to use the net HTTP package. And so we're going to make this a multi-line import. And now we're going to accept net HTTP. Stop. Cool. And basically what this is going to do is it's going to import the HTTP package used. And so we're going to now make a function, okay? And we're going to say that HTTP dot handle func, pass it slash. We're going to pass it the function. We're going to say, let's call this handler, and let's define handler here. The handler is going to be equal to itself. It's going to be a function. So we're going to say func is going to take in a write. So HTTP dot response writer. So when our response comes in to write to it, and itself, we're going to take in the HTTP request. And then what we're going to do is we're going to do func.f, printf, meaning print to another writer. We're going to print to the response writer, and we're going to say, hello, York University, exclamation mark. And we put it there. Then what we need to do is we need to say http.listen and serve. And let's give it port 80, which is the default HTTP port. And we're going to hand it nil for what it needs to do. Bruh. All these Go tools be out of date. I wish I could show you. So if we run this, it's going to give me a little pop-up because I'm on Windows saying, I'm trying to run a network thing. Oh, maybe not. Oh, I need to save because I'm not in that. So if I run go run now, undefined HTTP listen and serve is what I meant. HTTP listen and serve. I think I just need to reinstall my VS Code at this point, but it is what it is. So run this. Oop, HTTP listen and serve. Go run. I have a little pop-up on my screen. I'm answering about my Windows Defender firewall. Cool. And now we're going to open another terminal. And we're just going to curl. We're going to go localhost And you can see the content is hello York University. Let's see if I do localhost 80, if it'll give me something else. No, okay. Yeah, curl, let me try on select default shell. Cool. So let me open up a git bash. So if I do curl here, it'll be a bit easier to load. Curl localhost. Hello, York University. And this is actually a fully fledged web server. So let's try returning something like, you know, I don't know if it's going to be able to get it, but let's try HTML, H1 / H1, hello. And if we go back to our terminal, we end this. I'm going to do go build -o app and /app. This is why we use git bash. Go build -o app and /app. And /app. Cool. So now we have it. Cool. And so now this is running. And what I'm going to do is I'm going to maybe share. Can I open a web browser here? Well, this is what I'll do. Let me move my StreamYard more to my other monitor. Okay, cool. And let me share my whole screen now. And I don't want to ruin the surprise, so let me open a new tab. Okay. And so now if I pull up localhost 8080, or just 880, so localhost, we can see hello, and that's actually rendered in HTML. So right now we're actually already serving a live server, which is really amazing because what we have only took, like, look at this, really. We really have 5 lines of code, 4 lines like this. You know, you can just combine these 3 lines of code, really, and we're already serving a full HTTP server. Which is a super great value proposition. So there's tons more I can do. I can show people how to use JSON and how to, you know, build custom types into it. So maybe now we can open it up to Q&A, and I'll just keep coding away, adding a few more features. So does anyone have any questions about Go, about importing things? Maybe we can use Gorilla Mux. I'm going to be running some more tutorials over the next couple months to show people some of the more intricacies, how to develop servers and that type of thing. You know, we can see name, string, just add some things, you know, JSON, Alan, age. I'm just going to keep working away, adding some things for you folks to keep seeing. JSON, age, name. Cool. And actually, if we go to our Go by example and we go to JSON, we can actually even see really quickly how to do JSON stuff. And you know, we can see that we can make it quick encoder. You know, we'll say Alan : equals person Alan 22. Cool. Oh, I might be missing something in chat. Oh, never mind. I'm not. So if you have anything, please ask away. I'm going to just show you a bit more. You know, refresh this. And you can actually see that, oh, this is the way it's encoding. Okay. So you can see now that if we do this, we have the handler. We can actually return JSON now. So really simple. I wish we had a bit more time, but you can see that running a simple web server, we can return JSON, and I'll even make in a quick post endpoint. So you can see this takes in something. We can using this little examples page, we can make a post handler, and that will be that'll take in a func, and it'll be the same as up here because this is the same standard inputs and outputs. And what we'll do is we'll actually say our var person, and we'll use a JSON decoder by decoding the body. So we can just take the body and we'll put that into person, and then we can say fumt.println, person. You can even say received person. And that way, if I want to send something, so let's make sure this is saved, I can go and I can say curl minus s. We'll give it x post, and we'll give some data. We'll give it name. Michael, David, cool. Oops, that should be name, Michael, David, age, let's, just throw 20, and then I do localhost. We can see, oh, whoops, localhost. Let's try printf %v. Cool. And then I also need to say post. Cool. Let's go back here. Go build, post handler declared but not used. Oops. Take that there. Cool. Run our app. We're going to go /post. And localhost /post. Oh, the curl is wrong. And you can see, oh, just not, doesn't want to work with me today. I don't usually code like this, but try and do a quick thing for my folks out here. You can see we'll send the data. Oh, there we go. And you can see received. And so things didn't bind perfectly. It seems, name. Oh, so let's try this again. You see it didn't bind well. Let's try this way. Received 0 again as well. Age, name, takes an int. Things aren't always what you want, to be honest. But in the end of the day, hopefully you get it. I would suggest using the Gorilla Mux routing. It's a bit stronger and a bit better to make things work. You have to do a bit more of your Go tooling to get it there. So, if you want it there, you have to go get Gorilla Mux, and then you create your router separately. So you go router mux.new router. And this way, instead you can go to just handle func. So you can say, you know, stick this in here, stick this in here, you know, take this out. And then instead you can just go to our handle func, adds it to the go.mod file, build your app, undefined mux, doesn't import it automatically, mux, or github.com/gorilla/mux, just like that. Build your app, get to run, and pray to work one day. Received something, didn't encode perfectly, but you know, that's really the way it goes. Sometimes things are frustrating. Sometimes they don't always get your nice JSON working. You know, could be something, you know, like this should be maybe maybe like that. Who knows? Page not found because my life sucks, but you know, I'm sure if you tried, it'll be a lot better. I'm going to run some actual tutorials prepared to teach you how to make some of these awesome REST APIs, so make sure you tune into them. But beyond that, I think that really covers everything. I don't see many questions. I don't see many people watching. So if you have any other questions, please come join me in the GSDC Discord. I'll answer any questions there. Otherwise, please let me know if there's anything else. I'm going to close out the stream here. Thanks for everyone for tuning in, and we'll catch you at our next event tomorrow and at future Create Series events. See ya.